Why are arrays such a fundamental aspect of data structures? Well, imagine having a collection of items, say books, and you want to arrange them in a way that's easy to manage and access. You wouldn't just pile them up haphazardly, right? You'd probably put them on a shelf where each book has its specific spot, and you can easily find and retrieve any book you want. This, in essence, is what arrays in data structures do. An array is a type of data structure that holds a fixed-size sequential collection of elements of the same type. Just like the books on a shelf, each element in an array has a specific fixed spot, known as an index, and you can easily access any element you want using this index. To better understand arrays, picture them as a row of lockers at a train station. Each locker is an element in the array, and each locker has a unique number, which is the index. Inside each locker, there's an item, and all items are of the same type. You can use the locker number or index to quickly find and retrieve the item you want. Creating an array is like getting a row of empty lockers. You decide how many lockers you want, which is the size of the array, and what type of items you want to store in them. Once the array is created, you can't change its size or the type of items it holds. Adding an item to an array is like putting an item in a locker. You choose a locker, which is the index, and put the item in it. If there's already an item in that locker, it gets replaced. Accessing an item in an array is like retrieving an item from a locker. You go to the locker with the number or index of the item you want, and there it is. Arrays can be one-dimensional, like a single row of lockers, or multi-dimensional, like a grid of lockers. Multi-dimensional arrays are arrays of arrays, and each element can be accessed using multiple indices, one for each dimension. Now, why are arrays so important? They provide a way to store multiple items of the same type together, making it easy to organize and access data. They're efficient, as you can access any item directly using its index instead of having to go through all the items. They are versatile, as they can be used to implement other data structures like stacks and queues, and they are widely used in programming, from simple tasks like sorting numbers to complex algorithms in computer graphics and machine learning. So, to sum it up, arrays are like rows or grids of lockers. They hold a fixed number of items of the same type, each with a unique index. They are efficient, versatile, and widely used in programming. And just like a well-organized bookshelf, they make managing and accessing data a breeze.